next two rules. So the next two rules would be if my pH is less than the pKa. So again, there's a typo here. This should say greater than, right? Because there's two different rules. So let's start with the first rule. If I'm looking at a base, for example, let's say I want to look at an aromatic amine. Okay. If I put this unionized base in an acidic environment, so if I put this in an acidic environment with acids floating around, okay? If I put this base, unionized base, in an acidic environment, will that base remain a base? In other words, will that unionized base remain unionized? No. That base is being put in an acidic environment. It's attracted to that acid. It's going to grab a proton, and it's going to become its ionized form. So in other words, it's going to have this ionized form where you're going to have a positive charge on that nitrogen, and it's going to be an ionized acid. And so just so I can make this a little neater, I'm going to get rid of the previous example so we can really focus on bases right now. So with this base, notice how we started off with an unionized base, right? By now you should know why this is an unionized base. And then we're putting that unionized base in an acidic environment. Why is it an acidic environment? Well, because we're looking at number one here. We're looking at when the pH is less than the pKa. When the pH is the thing that's lower, when the pH is less, then that's an acidic environment, right? So therefore, the unionized base is going to become an ionized acid, and specifically, it's going to have a positive charge. So that's that answer. And then number two here, if I have the pH is greater than the pKa, so what does that mean? A high pH clearly means that I'm in a basic environment. Well, if I put a base, here's my base, and I put it in a basic environment, in other words, there aren't any acids floating around, there's no acids, then this unionized base is just going to stay an unionized base. So the unionized base is going to stay an unionized base. Sorry, it's really hard to say. All right, so when the pH is less than the pKa, when we're talking about a base, that's putting a base in an acidic environment, and so that means we're going to end up with an primarily ionized form as the dominant form. And then here in number two, when the pH is greater than the pKa, we're putting a base in a basic environment, and so it's going to stay unionized. In other words, it's going to remain as is. All right, so just to recap, how do you make, so you should be able to answer these questions. How do you make an unionized acid become ionized? So how do I make an unionized acid become ionized? I have to make sure that the pH is greater than the pKa. So that would be right here, number two. How do I make an unionized base become an ionized acid? Well, I have to put that base in an acidic environment. So the pH would have to be less than the pKa, like this rule number one over here. This is how I like to summarize it in my head. I like to think, well, if I have an acid, an unionized acid, how do I make that acid have a negative charge? Well, I have to put it in a basic environment, so I need the pH to be high. Whereas if I have a base, an unionized base, and I want to make that ionized, then I must put it in an acidic environment, which means by the definition that the pH needs to be low. So think of it whichever way you want, but make sure you memorize and understand that an acid, an unionized acid, these weak acids can either be what two charges? An acid can be neutral, right? That's the unionized acid form. Or an acid can have a negative charge if you remove its proton. So I can have this form of my acid, or I can have this form of my acid. So it's either neutral or it's negative. So make sure you pause the video here and make sure you understand that with these weak acids, they're either going to be neutral or negatively charged. All right, and then let's summarize with bases. With bases, with a base, right? Let's say NH3, right? That base is either going to have a positive form when you put it in an acidic environment or a neutral form when you keep it in a basic environment. So the acidic form would be that positively charged form when it gains an extra proton, so now it has 4 instead of 3. And then the basic form, the neutral form in the basic environment would just be that NH3. So here I have my positive form and I have my neutral form. So to add on to this summary, an acid can either be unionized, so it's going to have no charge, or it's going to be ionized with a negative charge when it loses a proton. A base is either going to be ionized with a positive charge when you put it in an acidic environment, or it's going to be unionized with no charge when you put it in a basic environment. So I have this in mind. Acids can be negative when put in a basic environment or neutral when put in an acidic environment. Bases can be positive when put in a neutral environment. Let me say that one more time. Bases can be positively charged when put in an acidic environment, or they can be neutral when kept in a basic environment. So can an acid, a weak acid, be positively charged based on what we talked about? The answer to that is no. And can a base, a weak base, be negatively charged based on what we talked about? No. And so that's how I like to think about